Okay, good afternoon. We have section 8-2. This should actually be 8-2-1 for day 1. We're going to talk about vectors in the coordinate plane. So the first topic is component form of a vector. When it's in component form, you will see these little vector component parentheses that are pointy on the edges. So component form translates a vector to the origin, and the component form of a vector, AB, with initial point A and terminal point B, is given by here. So you have initial point to terminal point, so A to B, where our A coordinate is x1, y1, because it's initial, so this is the first xy, and B is the terminal, so that's the second xy. So x2, y2. And we can take the x's and put to x2, the final minus the initial, and it will give you the x's, and the y final minus initial gives you the y component. So the example says, find the component form of vector AB with initial point A, -4, 2, and terminal point B, 3, -5. So in component form, vector AB, use vector brackets, and I'm going to take the x's, from the x from A and the x from B, and since B is the terminal point, I can see by looking at this notation, the arrow is above the B, so that means it is the terminal side, where the A is where the ray line began, so that's the initial. So I'm going to start with the 3 minus the x value of the initial, which is -4. And then I'm going to take the y's and do the same thing, the final y, which is -5, and subtract the initial y of 2. Oh, I didn't underline my 2. So put the x's together and put the y's together, and when I do the math on this, I have 3 minus -4, so that's 3 plus 4. So that gives me 7. -5, -2, so -5 minus 2 is -7. And there we have it, the component form. The next topic is magnitude. Magnitude of a vector in the coordinate plane. And here we have, if we have the vector with its initial point and its terminal point, then the magnitude is given by this with the absolute value bars around it. That is telling us the magnitude of vector V is equal to, and we have, this is actually the distance formula. And that is if we have the regular coordinate form of the vector. But if the vector is already in component form, so we have it with the vector parentheses, then the magnitude of the vector is equal to the square root of a squared plus b squared. Okay? So we're going to find the magnitude of vector AB with initial point A and terminal point B. So since I have initial point, terminal point, I know I'm using this formula, the distance formula, for the vector. So I'm going to set it up, absolute value of vector AB equals, and this is the square root of all of this, which this is really, I'm not even going to say that. I don't want to confuse anyone. And then I'm going to do parentheses squared plus the y's in parentheses squared, and I'm going to take the square root. And I know I'm going to be subtracting in each set of parentheses. So I'm going to do the x's. My x2, my final point has to come first. So since this is AB, again, B is the final point, and the x of the final point is 3. the x of the initial point is negative 4. Then I take the y of the final point, so negative 5. And the y of the initial point, 2. All right, so always compare and make sure you know which one is the initial and the final based on your notation. Don't just assume because it's second that that's it. Maybe I'm being tricky and I give them to you backwards. Just pay attention. Okay, so now I have this equals the square root of, in parentheses, I have 3 minus negative 4, and that's going to be squared, but that's 3 plus 4. So this is 7 squared plus, here I have negative 5 minus 2, so that's negative 7 squared. So this gives me 7 squared is 49 plus negative 7. Oh, I'm off the screen. Sorry about that. Negative 7 squared is also 49. 49 plus 49 is going to give me 98. So it equals the square root of 98. But I know I can break that down into a simplified radical. So if I can just look right here, because I know 49 is a perfect square, and I have 2 of them, so that's like 2 times 49. So I can split this up into 49 times 2 instead of 98. And the square root of 49 is 7. And what's left behind inside the radical is a 2. So 7 square root 2. Okay, so on the back of the notes page, 821, we are going to look at vector operations. So this is things you can do with vectors, regular operations. Add, subtract, multiply, divide. Well, we're just going to add, subtract, and multiply, actually. So we're going to do vector addition, vector subtraction, and scalar multiplication. Scalar meaning one piece, one component of the number. Not a vector that has both magnitude and direction, is just a scalar. Okay, so what this is telling me, without reading it because it'll just sound like a bunch of blah blah blah, is vector addition, vector A plus vector B. I'm going to add the x's and add the y's. So add x's and add y's. To do vector subtraction, similarly, I am going to subtract x's from each other. And same with the y's. Subtract y's. And then for scalar multiplication, in this case k is my scalar value. It's k times vector A. I'm going to multiply both x and y by the scalar. So multiply scalar value by x and y. So those are the operations. All right, here for the example, I have 2 examples to go with vector operations. We are going to look at these 3 vectors given. We have vector w, we have vector y, and we have vector z. So this first example is vector w plus y. So I'm going to use this one plus this one. So I'm going to do some vector addition. Well, and my note up here said that I'm going to add the x's and the y's. So this is going to equal, first I need to write out my vectors. So vector w plus vector y. So vector w, I have negative 4, 1. Plus vector y, 2, 5. Okay? So then to put them together, actually I can go ahead and, no, I'll do this. I'm going to take the x's, I have negative 4 and 2, and I am adding. So I'm going to do negative 4 plus 2 for the x. And then for the y, I'm going to do 1 plus 5, because that is the y values, 1 and 5. So this gives me vector negative 4 plus 2 is negative 2, and 1 plus 5 gives me a 6. And that's my result. I'm going to try one more. Feel free to pause it, try it on your own, and check if you like. So this example, we have vector z. Oh, that b is not supposed to be there. That was a typo. Don't worry about that guy. Minus 2 times vector y. There's vector y. And we have 2 times vector y. So it's a scalar multiple of 2. All right, so we'll start by setting it up from what we have. Vector z. Oops, that's not the right color I was going to use. We have vector z, which is negative 3 comma 0 minus 2 times vector y, which is 2 comma 5. So you're going to treat these vector parentheses just as you might imagine you would with a scalar. You have a 2 on the outside. Now I'm going to leave the negative and make this a subtraction since we haven't done a subtraction problem. So I'm just going to distribute the positive 2 into my vector. So that gives me, it doesn't change the first one, negative 3, 0. I'm going to leave it as subtraction. And then I'm going to make this a 4 and a 10. Because 2 times 2 is 4, 2 times 5 is 10. And now I have a vector subtraction. So I'm going to subtract a I'm going to, sorry, I was looking at something. I'm going to take the x's, negative 3 and 4. This is going to give me, and I'm going to subtract. Oh, I didn't mean to put parentheses there. Sorry, that's just where the x is in, so it's going to be a comma. And I have a negative 3, and I have a 4. So for the x's, it'll be negative 3 minus 4. And then for the y's, I have 0. And I'm going to subtract 10. Okay. So now I have negative 3 minus 4, which is going to give me negative 7. And 0 minus 10 gives me negative 10. So there is my result. One more topic for today's notes for Chapter 8, Section 2, Day 1 is the unit vector. We're going to talk more about a unit vector on our Day 2 notes, but for right now, a unit vector is a vector whose length has been scaled to a magnitude of 1 unit. You obtain the unit vector by dividing a vector by its own magnitude. Okay. And so we just did magnitude with the distance formula, so that's what we're going to use. So we have find a unit vector, this little symbol here, that's mu, with the same direction as a vector v. So the unit vector with the same direction as vector v given negative 2, 3. So I need to set this up. I'm going to say, so I need to find unit vector mu. So this is going to be mu equals, I'm using this here. No, it's a fraction. On top, I just have vector v, which is given right here. This could also have a little arrow. Sometimes in Word, it's hard to get the exact right notation. So negative 2, comma 3, that's the vector, and it's going to be over the magnitude of the vector. So the vector's magnitude when you're in component form is the square root of a squared plus b squared, which being this is a and this is b. So we have negative 2. If you're using a calculator, I know this might seem obvious, make sure if your value is negative and you want to square it, it has to be in parentheses, or it won't square the negative, it will just square the 2. Plus 3 squared. All right, so again, this is the vector, and this is the vector's magnitude. Okay, so I'm going to simplify this. On the top, there's nothing to simplify. So mu, the unit vector, is equal to, the numerator is still the vector, negative 2, comma 3, divided by the magnitude. So this is the part I'm going to simplify. So if I use my calculator and I put in the square root, and inside the square root symbol I have the negative 2 in parentheses squared plus 3 squared, and I hit enter, and it's going to tell me that, well, it'll give me a decimal because I can't. So if I ignore the square root and I just do negative 2 and square it, that's 4, plus 3 squared, that's 9. So I have 4 plus 9, that's 13. Square root of 13. 13 is a prime number. So we're going to leave that as the square root 13. All right, so now we've simplified it, and now we're going to split it into its two separate pieces, because in the numerator we have 2 pieces. Denominator we have 1, so that's the common denominator, and we can split it up so that mu equals, we have negative 2 over square root 13, comma 3 over square root 13, and we're going to put this in vector component parentheses. Yes, we have a radical in the bottom, but it's okay. We're going to leave it that way. We don't want to rationalize this. It would actually just make it more complicated and not very useful. So we're just going to leave it like that.